Hi everyone, welcome to today's session that is on Smart Utility Agent, which is built with LangGraph, LangChain, and LangSmith. Now, in this video, I will walk you through a smart utility assistant, an AI agent that can do arithmetic, tell you the time, convert units, count words, and look up country facts. And the interesting part isn't the tools themselves. It is how the agent decides when it needs one. So here's the plan. Here's the plan. I will start conceptually, then show you the graph that powers this. Then we'll go into the code and finish with a live demo, including the actual execution trace in LangSmith. So let's get into it. So this is the core concept. What is tool calling agent? Now, over here, now a plain chatbot only knows what's in its training data and the conversation so far. But on the other hand, the tool calling agent recognizes recognizes when a question needs something the LLM can't do reliably, such as exact math, real-time data, a private dataset. Moreover, a tool calling agent chooses the right function to call, feeds the result back into the conversation, and turns the raw results into a natural language answer. But the the key idea is the LLM never runs the calculation or lookup itself. It only decides when and which tool to call. It only decides when and which tool to call. Now, here's the problem statement that I have solved by building a smart utility assistant that understands users' question and decides whether it needs to call a tool or not. Now, this assistant supports 5 tools. One is calculator tool, another is date time, current date time, then unit converter, convert units, text word counter, text underscore counter, and country lookup from a local data set. Lookup country information. And this each one maps to a single focused Python function. Okay. This is a Python function. This is a Python function. This is a Python function. This as well and this as well. I'll show you when we will get into the code base. Now, here's the high level architecture. Not very clear. Let me show you over here. Right. Now, if you see this properly, there are 4 layers. One is presentation layer. That is the Streamlit app that I built. Then orchestration layer. That is LangGraph. Then intelligence. That is LLM. And the tool layer. The 5 tools and the data set. And the data set. Here's the data set. Okay. So here's the full picture. Right. Okay. Now here's the full picture. Okay. Now what happens over here, the user types in to a Streamlit chat box. The user, the user types into this Streamlit chat box. Okay. Now that becomes a human message. Okay. Sent into the graph at start, which invokes LLM with a system prompt. Okay. Now I have to just rub this all over again. Okay. Now, if the model decides that it needs a tool, then what happens? This tool conditions routes into the tool node, that is tool call requested. The tool, the tool, this tool runs the same plain Python functions. Okay. This is a function, function, and function. Okay. And the result goes back into the agent node. So from here over here, that is tool results appended to message state. Okay. Okay. Now this agent node calls the LLM again with that tool result. You know, the tool result that came from here. Okay. So it calls the LLM again with that tool result, now part of the conversation. And tools underscore condition checks its response all over again. Okay. Now this can repeat more than once. This can repeat more than once only when a pass through the agent node produces a plain answer with no tool call. So when there is nothing to go to route anything to the tool, it straight away goes to the end. That is no tool call. Okay, no tool call. And that's the only path back to the UI as the final answer. Okay, now over here, it goes back to the same UI as the final answer. I think again this is creating some kind of problem. Okay, to the final answer. So this was the high level architecture of this app. Okay, so in short, user types into Streamlit chat box, that becomes the human message sent to a graph at start, which invokes LLM with a system prompt. Okay, and if the model decides that it needs a tool, so this tool underscore condition, okay, this routes to the tool node, and then the tool runs the same plain Python functions. Okay, and then the result, this result over here goes back to the agent node. Okay, now this process repeats for some time until there is no tool call and it straight away goes to the end. And then the final answer goes to the, this final answer over here, this final answer over here, this final answer over here goes to the Streamlit chat UI, giving our end user the answer to the query. Okay, so this was high level architecture. Now, let's see. Okay, now if you see over here, there are exactly two nodes, agent node and the tool node. Okay, this tools underscore condition, which I was talking about in that architectural diagram, it's a pre-built LangGraph function. That's okay, I think correctly. Okay, okay, let me show you the code base for it. Okay, Okay. Now, if you focus over here, mm, okay, come over here, create a smart utility agent. Now, the whole thing is only two nodes, the agent node and the tools node. As I said, tools underscore condition. This tools underscore condition is a pre-built LangGraph function. It just checks whether the last AI message contains a tool call. If it contains a tool call, we go to the tools. If not, we go straight to the end as it was given in the architectural diagram. Okay, I explained you that part. And after the tool runs, the edge sends control back to the agent. Okay, not to end. Again, it was in the architecture diagram. Okay, so the model always get the last word over here. Okay, I hope you're getting what I'm trying to say over here. Now, let's check the anatomy of the LangChain tool. If we are, okay, let's go to tools.py. Now, just focus on these four lines. Just focus on these four lines. Now, this at the rate tool, okay, this is a decorator that turns a normal typed Python function into something that LLM can discover. Now, this doc string, it is not a comment. It's what the LLM reads to decide when to call this. So if you get this doc string wrong or vague, and the model will either miss it or misuse it. Okay, so this is very important. Okay, then we have these type hints. That is, operation is string, this A is float and B is float. This type hints define the exact arguments the model must supply. Okay, because this is a calculator tool, so a number, so this has to be float and this has to be a float. Okay, and whatever comes out, it has to be string. Okay, now let me walk you through all the five tools. Okay, this is calculator tool, this is current date and time tool. Okay, now if you focus on this calculator tool, it actually what it does, it adds, subtracts, multiply. That is plain arithmetic that it is doing, plain arithmetic. Okay, now if you go to this tool, current date and time, okay, this reads system clock, converts to Europe London via zone info. Okay, because I've set this to Europe London, and returns date and time in a readable format. Okay, then third tool is convert units. This is hard coded conversion. Okay, like factors from uh, kilometers to miles, miles to kilometers, meters to feet, feet to meters, then kilogram to pounds, pounds to kilogram, like this. Okay, then we have text counter tool. Now what it does, it counts words. It counts words once the text is split, then it counts the words. Then we have characters with and without spaces, and then sentences, that is regex expression. Okay, regex expression. And last but not the least is the lookup country information tool. Now this country tool just loops through a JSON file that I've created, this one, this JSON file. Okay, Mm, okay, where were we? We were in tools, right? We were in tools. Okay. See, uh, okay, we have over tools also. Okay. Now look at this bottom. What is happening over here? Now all five decorated functions get collected into a single list. Okay. Now this list, this particular list, this particular list gets handed to the LLM. Okay. Gets handed to the LLM. But the most interesting part, if you think about it, what is the most interesting part over here? The most interesting part is that only AI driven part of this whole file is that the model decides which function to call and with what arguments. Everything after that is deterministic. Okay, everything after that is deterministic. Now, uh, let me show you a couple of more important things in the code base. Agents.py. Now, if you go to this particular line, llm.bind underscore tools. Now this bind underscore tools gives the model visibility into those five functions, the five tools. Okay. This sends the function name. This sends the this sends the function name, docstring, and argument schema to the model on every call. So it can emit a structured tool call instead of free text. Okay. Now, see, what we are discussing over here is that how LLM selects the tool. So I'm explaining you that, how our model selects the tool. Now let's go to llm.py. Now, if you focus on this temperature is equal to 0 that I have set, as I was telling you about deterministic, this is what deterministic means, which means I want consistent tool routing behavior, not creative variation. I want consistent tool routing behavior. Okay. Not a creative variation. This is what it means. Okay. So every time I ask the same question, I get a consistent behavior, not any creative variation of it. Okay. Now let's come back again to agents.py. There is agents.py. Here is agents.py. And let's discuss about this system prompt. Okay. Now focus on these rules. Just focus on these rules. If the question requires mathematical calculation, you must use calculator tool. If the question asks for current date or time in the United Kingdom, you must use the current date time tool. Okay. So similar rules for unit conversion, text counter, okay, and country lookup and country lookup. Okay. And a fallback over here. If the question does not require a tool, answer directly. So this part, this this whole part, that is, you can say the rules, the rules, this whole part controls model's behavior. It controls model's behavior. It controls model's behavior. Instead of leaving tool choice entirely up to the LLM, the system prompt gives must use rules per category. Must use rules per category. Okay. Let me give you an accurate picture of behavior of those system prompt rules. If I go to readme.md preview, okay, now try to understand this thing. Now what is happening? Incoming request is coming. Okay. Now it says this are what we used to call this thing. That was some word related to this. Tools condition, right? Tools condition, right? So incoming questions come, incoming question, a query. Okay. So this particular part, the tools condition part, it says need math. It says yes, call the calculator tool. If no, it goes to another tool. Need UK date and time. It say yes. If it says yes, it goes to this tool. If no, it checks for another condition. Needs unit conversion. Okay. If it says yes, it goes to convert units tool. If not, then it goes to another condition. And then another condition. If yes, then look up country information. If no, answer directly. It means no tool call. So this is the accurate picture behavior of the system prompt. Behavior of system prompt. Okay. Now let's talk more about agent node. Agents.py I have. Let's talk more about agent node. Yeah, I have this agent node. Now, I want you to focus on these three lines. Uh, Let me fix that for you. Okay, let it be like this. Okay. Now, let's focus on these three lines. Okay, what is happening over here? This line one, this line one builds the system prompt. This line two sends the prompt plus the whole conversation to the model, LLM with tools dot invoke sends the prompt and the whole conversation to the model and waits for a reply. This line three hands that reply back to the graph. It hands that reply back to the graph. Okay, and that's it. It doesn't check whether the reply is a normal answer or a tool call. That check happens right after over here in tools condition. Over here in tools underscore condition. Okay. Now, mm, now let's work around a demo. Mm, okay. Hmm. Yeah, I think I tested this. Let's see if it is working properly or not. I built a small app in Streamlit to show you some kind of a UI interface. Streamlit run. main.py. Okay, let's say, hi, how are you? Let's see what it answers. It says, I'm just a program, but I'm here and ready to assist you. How can I help you today? Okay. Now, this is the direct answer over here. It is not calling any of those tools, any of those calculator tools, current UK datetime tool, or unit conversions, or sentence counters, word counters, or country information. It is giving me a direct answer. It is not calling any tool. Now, let's write something so that uh, I had, okay, let me write that for you. Calculate 20, 20% of VAT on 80,000. Let's see what it does. Okay, okay. It is giving me. Okay. Did you notice something? Did you notice something over here? Let me write all over again. Calculate 18% VAT on 1,000. Now I want you to notice something. There, see what is this? This is a spinner. This is just a spinner. It means that's the graph doing agent, then tool, then agent again before anything renders. Okay. Okay. Let's try another query. So over here, a tool was called, and the expected tool that was called was calculator. Okay. Now let's try another question. Convert 20 kilometers into miles. Let's see. So like it will again call the tool, and that's convert unit. So we got the answer. Okay. Now, uh, let's come over here and I want a paragraph from somewhere. Suppose, for example, let's go to ft.com. Okay. And we just want to, let's go over here to just count the words. And let me ask a question. How many words are present in the following paragraph? I'm just doing an experimentation. Let's see. Okay, the paragraph contains 131 words. So the expected tool that it called was text counter, right? Text counter. Let's try a couple of more. Uh, Now this one is interesting. I think I haven't shown you. If you come over here and if you go to the system prompt, read this example. Okay. What I'm asking from the tool through system prompt is that first calculate 12% of 50,000 and then add it to 50,000. It means it will call the calculator tool twice. And the question is whether it will follow this sequence or not. That's the question. Let's see. What will 50,000 become after adding 12%? 56,000. So it worked. It worked. It computes the percentage and then adds it exactly like the system prompt instructs. Okay. Now let me ask uh, today's date. So all these queries are calling the tool. All these queries are calling the tool. See? Okay. What are the capital and currency of United Kingdom? And the currency is pound sterling. So all these were calling the tool, but the one which was not calling the tool was the first one. Hi, how are you? Now, this is a plain conversational message. No tool needed, no tool node hop, and we get a straight answer. Okay. And we get a straight answer. So we are done with the intro, architecture, understanding of the codes, running the queries that we did just right now. Now let's move toward tracing to show how you exactly means uh, tracing it to show what the model sees and decides, not just the final answer. I mean to say, now we want to see uh, not the like the we want to see the transparent picture of the opaque black box. So let's get into the LangSmith, okay, which is also useful for debugging wrong tool selection, checking latency, and verifying the system prompt rules are actually being followed or not. Okay, because see, here we are putting the information, querying it, and getting the answer, but we don't know what is happening behind it, how the tools calls are working. Okay, let's come over here. Let me see. This is the project. Okay. Now, okay. These are the ones. Okay, let's try one by one. Okay, let's try this. This is the latest one. Now, this is the input. What are the capital and currency of United Kingdom? Okay. Now, AI called up this tool, look up country information twice. United Kingdom, United Kingdom. Now it says United Kingdom, London, pound sterling, 68 million. It gives me the whole bunch of information. But here's the answer from the AI. The capital of United Kingdom is London and the currency is pound sterling. So the moral of the story is that it called this tool, look up country information. Okay. Now let's check another one. The interesting part one. This one. So this is the input. Here's the output. Sorry. Yeah, here's the output. User asked this. This was the calculator tool, which is doing the percentage. It got the percentage, 12% of 50,000. That's 6,000. And then again, it called the calculator. That is, it added 6,000 with 50,000. That is 56,000. So that system prompt worked. And after adding 12% 50,000, the total becomes 56,000. Bingo. Now, let's check this one. Hi, how are you? I'm just a program, but I'm here and ready to assist you. How can I help you today? So no tool calling over here. So no tool calling over here. Okay. So that's it. This is the smart utility agent here for you. Okay. So we have covered almost everything in this. So what are the key takeaways from here? What are the key takeaways, or what did we learn today? First, a tool call, a tool calling agent is equal to LLM for routing plus phrasing. Okay. Then LangGraph makes the loop back to the model after a tool runs. Third, a good system prompt does more routing work. And LangSmith, LangSmith turns an opaque into transparent step by step debugging trace. Okay, debugging trace. So this is what we learned today. Okay, so I hope you have got really fruitful learning of this an AI agent, that is smart utility tool agent. Okay, you can get the code base from the description box of the video. I'll put a link over there. Okay, you can fork it or clone it to create your own agent or add a new agent or to play around with it. Okay, and if you like this video, you can share it or subscribe it. Okay, so that other also get to know what is happening, in this industry, or what kind of, good AI agents are walking around with us now these days. So in the next session, I'll discuss something very interesting. Perhaps would be coming with another agent, as I've discussed two agents now. One is this one, the smart utility tool agent, and another one was the React agent, the reason and the acting one, the reason, acting, observing, and doing a lot of stuff. I want you to go through that video if you have time. So I'll see you again. In the meantime, happy learning and see you soon.